All right, good morning. So what we're going to work on today is we're just going to work on extra practice for 5-3, specifically solving using our calculator and using what we know about the properties of the unit circle to solve things that maybe we wouldn't be able to solve traditionally with a unit circle. So what we worked on last time, and I know there was a little bit of confusion here, we're going to just keep on practicing with this. We kind of compared this first question, the sine of theta is equal to half, seeing that I get two solutions here. I get pi over 6 and I get 5 pi over 6. Changing my question ever so slightly, we tried, what happens if the sine of theta is equal to a third? Well, what that means is that, well, if sine is positive, sine has to be in the first and the second quadrant. I honestly don't even need to write like an accurate graph. All I know is if sine is positive, it's got to be above the x-axis. So I know my two angles are going to be those blue angles there. So what I did is I used inverse trig to get my first answer. So this is the reason I drew this picture, is that my calculator does not give me two answers. And the reason it doesn't is because when I use inverse trig, I am inherently restricting my domain. So what I got here was I got 0.339, and I wanted to know what must the other answer be. Well, the other answer is going to be in the second quadrant. In order to get there, I'm going to go all the way to pi and then stop short of pi. In essence, what I'm going to do is I'm going to go all the way to pi minus 0.339. So that's what I did last time. I want to do a similar question. Ooh, I can't breathe for a minute. All right. I want to do a similar question. So the next question that I want to try is this. What happens if I have tangent of x is equal to, I don't know, we'll say 1.2. In fact, we'll even say negative. Tangent of x is equal to negative 1.2. So the first thing that I want to do is I want to determine on my unit circle, where is tangent going to have a negative value? Where is tangent going to be a negative 1.2? Well, that requires me to make that statement, all students take calculus. So if I write all students take calculus, tangent is positive. Well, in the all section, every single function is positive. So like tangent is positive, sine is positive, cosine is positive. And so that first quadrant, tangent's positive. In the second quadrant, it starts with an S, which is really trying to say that sine is positive. In the third quadrant, it says T, which means T is going to be positive here. And if you want to know, besides just blindly memorizing, all students take calculus, tangent is positive here because every single value in the third quadrant is going to be a negative value followed by another negative value. Well, tangent is a fraction. Tangent is y over x. So if I say negative y over negative x, I must get a positive value here. So if tangent is positive in the first quadrant and it's positive in the third quadrant, it's got to be negative in the other quadrant. So the quadrants that I'm looking for here is I want to have answers in the second quadrant and in the fourth quadrant. That's where tangent's going to be negative. So that's where tangent is going to be negative. So I'm just going to actually, just from now on, I'm just going to generically write some sort of angle in the second and the fourth quadrant. It doesn't have to be super accurate. I just need to remember that I have an answer in the fourth, and I have an answer in the third. All right, so what I want to do next is I want to take the inverse tangent. That is what's going to solve, my question for x. So I'm going to take the inverse tangent on both sides. All right, so if I take the inverse tangent on both sides, my calculator is not showing up on the browser tab today, so you're going to have to click second tangent to get inverse of negative 1.2. All right, so we are going to say that tangent of x, we're going to say that x, in fact, I think my mode might be in degree. Yep, it is. What I originally got was negative 50. In fact, actually, it might be kind of easier for us to work in degrees. I'm gonna keep it in degrees for a minute. So I got negative 50.194. So what it's saying is that the first answer is negative 50 degrees, 194. For negative 50.194 degrees, I guess. That would be a little better notation there. So what I'm saying is that my first answer is going to be in the fourth quadrant. It's down here. And now I'll go ahead and also write it in radians because oftentimes I'm going to ask you the answer in radians. So the answer here is also negative 0.876. Okay, in radians. So in radians, I'll just kind of keep that in yellow, negative 0.876. So that's one of my answers. We're actually halfway there. The next answer that I want to have, though, it has to be in the second quadrant. So I just want to think through this. How am I going to get that answer there? Well, just looking at this graph, looking at the unit circle here, it looks like I'm going to go up this much, and what's left over, this leftover piece, even if I want to use kind of like alternating interior angles, has also got to be 50.194. So this degree measure here is 50 degrees, 0.194. So the whole degree measure is going to be 180. And so if I did this one in, I guess I should write it in red so we can kind of stay consistent here. So the whole degree measure here is going to be 180, which is the whole line, minus 50.194. So in degrees, my answer is going to be 180 minus 50.194, giving me 129 degrees, 0.806. And we have both our answers, but let's just go ahead and write the other one in radians. So in yellow, I'm going to do this in radians. Okay, same thing, same process. What is 180 in radians? Well, 180 in radians is pi. So I'm going to say pi minus 0.876. So I'm going to go and find out what that is. So pi minus 0.876. Pi minus 0.876. And I'm going to get 2.265 radians. All right, so I also have that x is equal to 2.265 radians, or alternatively, I could write it as x is equal to 129.806 degrees. In fact, let me go ahead and write this one in yellow here just for consistency's sake. Okay. Now, I want to have this answer generic. I want to have it on a generic open interval. In order to write these answers generically, all I'm going to do is add the period of the base function times n. So, in the case of something that is in degrees, I'm going to say, well, the period of tangent is pi. Pi in degrees is 180 times n. Same thing here. We'll say plus 180 n. So that is my answer if I answered in degrees right here. My answer if I answer in radians is going to be this. I'm going to say plus the period of tangent, which is pi times n. This one's going to be plus the period times n. And this is my answer in radians. Okay? All right, I'm going to have you guys try another problem. We'll probably go through about 3 or 4 of these problems today, and we'll see if we can kind of end on, I guess, the most difficult problem, which is using this in context of quadratics. All right, so the next question is going to make this up. Let's see. Let's try something we haven't tried in a minute. Let's try cosecant. Let's say that cosecant of x is equal to negative 4. So I want to solve this first. Because I don't have an arc cosecant in my calculator, I might want to take the reciprocal on both sides. So really, another way of thinking about this is I could write it like this. Cosecant of x is the same thing as 1 over sine x. And negative 4 stays the same. To solve this in terms of sine x, I could multiply by sine x on both sides. And so what I get is 1 is equal to negative 4 sine x, and if I divide by negative 4 on both sides, I get negative 1/4 is equal to sine x. So that's kind of like the process there, or you could just take the reciprocal of both sides. That's totally allowed. Okay, all right, so what I want to do to solve is I'm going to take the inverse sign. I'm going to take the arc sign. So I'll say sine inverse on this side, sine inverse on this side. The reason I'm doing this is that the inverse sign cancels sine out. And so what I want to know is what's the inverse sign of negative 1/4. So I'm going to go ahead and write that. The inverse sign of negative 1 divided by 4 is, in radians, in radians is going to be, and I'm going to keep with that process of doing degrees and radians. So in radians, we're going to say that x is equal to negative 0.252. And then in degrees, it's going to be, I guess I didn't press enter. Negative 14, so let's write this one in red. We'll say x is equal to negative 14, oh no. Okay, negative 14.477 degrees. Okay, so let's go back up there and let's get a unit circle going so I can think about where my answers should be. Okay, so I have sine of x is equal to negative a fourth. So what I'm saying is that the y value is negative a fourth. So on my unit circle, I want to just pick where is sine negative. Well, sine is going to be negative in the fourth quadrant, and it's going to be negative in the third quadrant. So instead of thinking about all students take calculus, you could honestly just think, hey, when do I have a y value that's negative? That's always below the x-axis. And so my answer is going to be in the fourth quadrant, and it's also going to be in the third quadrant. It's kind of easier for me to see maybe negative 14.77 degrees. So I'm going to go ahead and sketch in negative 14.77 degrees. Maybe it looks like this. In fact, it's probably smaller than that. Doesn't really matter though. So this right here is negative 14.7477 degrees. Okay, so that's my first answer. The next answer I'm going to have is going to be the same distance down. So it needs to be the same amount y value down. So it needs to be almost just reflected across the y-axis. I want to have the same y value. So whatever this is, I want to have a y value of negative a fourth. So I don't know the x value, but let's say I want to have a y value that says I'm going down a fourth. And I want to say I'm also having a y value that goes down a fourth. All right, so to find the other angle, there's a lot of ways I could do this, but what I kind of see, the first thing that I see is that I go all the way 180 degrees, and then I go an additional 14.477. So what I'm going to say is I'm going to do 180 plus 14.477. Okay. And so I'm going to get 194.477 degrees, which makes sense. It should be slightly over 180. If I want to do this in radians, well, in radians, this is negative 0.252. So I'm going to go all the way halfway around the circle, which is pi, and then I'm going to add the same angle, which is 0.252. So I'm going to say pi plus 0.252, and I'm actually going to use my calculator there. Let's see. Pi plus 0.252 is going to be 3.393 radians. And so if I want to write these answers generically, let me go ahead and write my x value here again. This is going to be 3.393. And my y value, my x value in degrees is going to be 194.477. If I want to write these generically, I'm just going to add the period. Well, the period of cosecant, or the period of sine, is 2 pi. So I'm going to say 2 pi is the same thing as 360, so I'll say plus 360n plus 360n. And in yellow, and once again on a test or quiz, you're not going to have to write both. I would probably prefer that you write it in radians because AP Calculus is usually in radians. So we're going to say, this first one we're going to say plus 2 pi n, and this one we'll say plus 2 pi n. Okay, all right, so at this point we've tried two kind of basic practice problems. I want to go ahead and try that bigger problem. So the bigger problem that we have here is this question right here. Using your calculator, I want to know what's cotangent squared x minus 10 cotangent x is equal to 3. And I am going to I think I'm just going to go on Desmos for this, and I'm going to just kind of tell you what you could write in your calculator. So what you could write in your calculator. So let me just go through both of these, and I can only show you Desmos because I'm on a web browser. So what you could write, cotangent squared x let's go ahead and get everything to one side. So cotangent squared x minus 10 cotangent of x minus 3 is equal to 0. To find the solution here, if you want to put this in your calculator, there is no cotangent button, but there is a tangent button, and tangent and cotangent are inverses. So, not inverses, reciprocals. So what I could write in my calculator, so if I was writing this in my calculator, what I could write is this, parentheses, 1 over tangent of x squared, like this, minus 10 divided by tangent of x minus 3. Okay, and I'm going to go on Desmos now. I'm going to show you what that solution is going to look like. In fact, I need to switch my web browser. I don't know if it's going to let me. Oh boy. And you know what? I'm going to write it on Desmos real quick, and I'm going to screenshot it over so you guys can see it. All right, so what I want to graph, what I'm really trying to graph here, just kind of remind myself, cotangent squared x minus 10 cotangent x minus 3. So I'm going to go ahead and write that on Desmos. In fact, I'm going to pause the video so you guys don't have to sit there and listen to me type. Okay, so I'm back. I graphed it on Desmos, and actually what's really cool about Desmos here, as long as I understand the period of cotangent, I can actually get all of my answers using something like Desmos. So what I want to look at here is the answers that, in fact, I don't think I clicked on one of them. Let me go fill it in. I don't think I clicked on all of them. Oh yeah, I did. All right, 0.097. Okay, sorry, I gotta add this one. So this point right here is 0.097. So those are all my points there. Okay, so actually, if I think about cotangent for a minute, look. If I look at the answers that I'm getting oh, I did have that written. Not bad. Okay, so I'm getting 0.097 here, and I'm getting this point, negative 1.287. I also have this point right here, and then I also have this point right here. So what I want to do is I want to use that to see if I can get some sort of solution graphically. So using my graph calculator. In fact, I'm going to add one more point. This is 3.32. This is 0.3238. So 3.238. 3.238. That's that point right there. All right, so what's really awesome about Desmos is Desmos can actually give me a bunch of solutions without having to use that whole inverse trig thing that has really been I guess, making our lives a little bit difficult. So what I'm going to do is I'm going to start off with this 0.097. So on my unit circle, what I'm saying is that cotangent, and I want cotangent, in this case, I want cotangent to have its first output in the first quadrant. It's going to be positive here. And so what I'm saying is that one of my first solutions is this really tiny 0.097 radian degree. And then I have another value, negative 1.287. I'm going to go ahead and graph that too. If I think about what pi over 2 is, pi over 2 is like 1.57. So negative 1.27 has got to be somewhere here in the fourth quadrant. That's that negative 1.287. This one is 0.097. Let's go and define some more. 3.238. That's a little bit bigger than pi, which means that there is another angle here at 3.238. And then I actually think I forgot to write down one more. Let me see if I can grab it. The other angle I think I forgot to write down was negative 3.045. So I think there's one more here at negative, in fact, I think that's that point, negative 3.045. All right, so if I think about negative 3.045, that is slightly less than pi. It's a little bit less than pi, which means I have another angle right here at, I have another angle here, which I think is going to end up being this same angle here. So what I want to do is I want to find that final angle. And I can actually do this if you click on Desmos enough, you'd actually find you'd find the correct solution here. So I want you to take a look at all of these values and see if you can come up with what this final angle is going to be. And if you want, I encourage you to go on Desmos and see if you can find the final solution, because the final solution is actually written on Desmos too. So go ahead and take a pause and see what you. Okay, so I'm going to show you how to get this solution both using Desmos and using the unit circle. So the point that I'm kind of missing is most related to negative 1.287. And the reason I know this, if I just connect the diagonal here, I can create kind of like, I can create an angle that's really, really similar. In fact, we're going to actually kind of use alternating interior angles a little bit here too. I guess more like not alternating interior, I guess more like vertical angles. So to find this angle here, if I go down 1.287 radians, to get to this angle here, I need to go almost to pi. And the amount that I'm short is this distance right here, not distance, this angle, 1.287. And so to calculate that, I'm going to say pi minus 1.287. And let's see what we get. So if I say pi minus 1.287, what I get is 1.8545. So I get 1.854. And that right there is actually my final angle, 1.854. All right, so what I want to show you guys is something cool because we kind of are in the online era. I'm going to go ahead and show you how Desmos is going to show you pretty much the whole solution. So I'm actually going to take this out. I'm going to copy and paste what I have on Desmos. So on Desmos here, we can see that actually all of the solutions are represented. We have that we have 1.287. We have the negative 3.045, which actually I think is out of our region. We have 0.097. We have 1.845, and I have the 3.2838. And so what I want to take a look at here is how do I know when to cut off my solutions? Because if you look on Desmos, there's going to be infinitely many solutions here. And what I would suggest to you, draw a unit circle. Once you fill it up with at least 4 values, you can't really have any more values than that. So if I think about it, I usually take a look at the value that's closest to 0 because that's what my calculator would have given me. And then I take a look at a value to the left that's also closest to 0 because that's also what my calculator would have given me. If I take a look at these 2 points here, these 2 points here are going to be my kind of starting points, and they're going to tell me the rest of the solution. So 0.097 is going to be related to this point here, 3.3238, and negative 1.287 is going to be related to this. Where am I at? Is going to be related to. Let me even look at my graph. 1.84854. So you can see here that this solution right here is actually not needed anymore because it's kind of like a repeat. It goes outside. We can actually see that the first 1, 2, 3, 4 points are going to be the points that I'm using within my unit circle. So I hope you guys use this as a tool. So when you're doing your WebAssign, feel free to go on Desmos and get those first couple of answers. It's a lot easier to obviously input something that's in quadratic form onto Desmos. So in the future, we are going to practice more of this. So on Monday and Tuesday, we're going to just kind of have some work days where we work and practice on these types of problems. But given that we're in the online environment, we are going to start to embrace using Desmos, which is probably going to be a good thing for you. All right, I hope you guys have an awesome weekend. I will see you next week.